elements. So இப்போ நம்ம பார்க்க போற ஒரு டாபிக் என்னன்னா capacitance of a parallel plate capacitor. So we all know that a capacitor is a device which stores charges. So it is just like a water tank which stores water in it. Now let us look at the capacitance of a parallel plate capacitor with dielectric field. What is meant by dielectric? So a dielectric is an insulating material which prevents the flow of current. Example, here the dielectric which is used in between the two plates of a capacitor can be ebonite, that is hard rubber, mica, oil, etc. Now we are going to look at a derivation for the capacitance of a capacitor. With dielectric field. So here this is parallel plate capacitor. Right. Now let us draw a simple diagram. Take two plates. One plate has been positively charged. The other plate has been negatively charged, which has ground. Then if I introduce a dielectric slab of thickness T, the distance between the two plates is taken as D. So here the distance between the plate and the slab is taken as D minus T. So here air is present, here the medium is the dielectric slab. So if air is present, certainly we have to look for the epsilon naught, that is the permittivity of free space. Here in the case of dielectric slab, which is an ebonite or mica or oil like that, we have to use epsilon naught into epsilon r, where epsilon r is called as dielectric constant or relative permittivity, which has no unit. Now see, the capacitance is a property of storing charges in a capacitor. That is what we call as the capacitance. Now if I introduce a dielectric slab between the two plates of a capacitor, certainly the capacitance value will keep on increasing. So the storage capacity will keep on increasing, because we know that capacitor is a charge storing or storage device. Now first I will give an idea. See, remember EVC. So this is the mnemonics we have to remember. E for electric field, second V for the potential or voltage, C for capacitance. So first we know that we have to find out the electric field in the region between the plate and the slab, and also we have to find out the electric field in the dielectric slab alone. So first the electric field between slab and plate is taken as E, which is nothing but sigma by epsilon. So according to Gauss law, the electric field between the two plates of a capacitor is always sigma by epsilon naught. For single plate, it is sigma by 2 epsilon naught, right? Now the electric field in the slab itself, so is taken as E dash, which is nothing but sigma by epsilon naught into epsilon r. And we know that according to the relation between the electric field and electric potential, we know one formula. So that is dV is equal to minus E into dr. But this formula can also be written like this: V is equal to E into R. So potential is equal to electric field into the distance. Now, first we need to find out the total potential both in air as well as in the electric slab. So the total potential developed is V is equal to V in air plus V in slab. Now let us continue here. So V is equal to V in air is nothing but the electric field into the distance. So the distance between the slab and the plate is d minus d plus V in slab, nothing but the thickness of the slab has to be taken as the distance. So E dash into T. E dash is the electric field in dielectric slab. So sigma by epsilon naught into d minus d plus sigma by epsilon r into T. So this is the total potential developed in the capacitance of a parallel capacitor with dielectric field. Then we know the formula for civic, CV is equal to Q, civic. We can use the mnemonics as civic. So from this formula, C is equal to Q by V, where Q is nothing but, we know that the surface charge density sigma is equal to charge per unit area. So Q is equal to sigma into area. Now let us replace Q by sigma into A divided by capital U. Now let me rub this. So C is equal to sigma A by V. The V formula has to be substituted here. So sigma by epsilon naught, taking commonly sigma by epsilon naught outside. So d minus t plus p by epsilon r. So sigma gets cancelled. The formula will be epsilon naught A d minus t plus t by epsilon r. This is the formula for the capacitance of a parallel plate capacitor with dielectric field. So now let me rub this. There is a small formula. So we know that the capacitance of a parallel plate capacitor with air field means C is equal to epsilon naught A by D. This is the formula for the capacitance of a parallel plate capacitor with air field. But the capacitance of dielectric field means then epsilon naught into epsilon r A by D. Now dividing C dash by C, we get epsilon naught r A by D over divided by epsilon naught A by D. So epsilon A, D cancel, we get epsilon r. So C dash is equal to C into epsilon r. This is a simple formula for which we need to use some problems. We can apply this for numericals. I think you would have understood. Thank you.